So epilepsy affects about 1% of the human population. And for most epileptic patients, the first line in therapy, that is anticonvulsant drugs, tend to be pretty effective. But for those patients that are refractive to this type of therapy, there are limited options. And the problem also with anticonvulsants is they don't really get to the underlying pathophysiology of epilepsy. They work more on the seizure symptoms, but not really improving the GABA-glutamate ratio in the hippocampus that we want to see as an effective therapy for epilepsy. Now, one therapy that has been proven effective for about 100 years is the ketogenic diet. So this is a high-fat, high-protein, low-carbohydrate diet that is actually pretty effective at a number of neurological diseases, including epilepsy. But how this diet imparts its therapeutic activity is really unknown. A group at UCLA hypothesized that the gut microbiome potentiated a lot of the effects of the ketogenic diet in having this seizure protection in epilepsy. And so to test this hypothesis, they developed a series of mouse models where they could test directly how the ketogenic diet imparts its effects through the gut microbiome. And so only mice with an intact microbiome, so those that were either not germ-free or didn't have their microbiomes knocked out by broad-spectrum antibiotics, showed this protective effect of the ketogenic diet, really proving that the gut microbiome is responsible. And they did some really fascinating work with metagenomics to identify which microbes seem to be most responsible for the effect. So species of Akkermansia and Parabacteroides seem to be the most effective at potentiating this protective effect of the ketogenic diet. And these bacteria alone were sufficient at imparting this protective effect. But that really doesn't tell you the actual mechanism of how the diet works, and it also poses problems for translating such a probiotic type therapy to humans, because you essentially have to reinvent the wheel and discover which microbes in humans are imparting a similar effect. So to really get at the mechanism, the researchers turned to global metabolomics. And what they found were that an entire class of metabolites called gamma-glutamyl amino acids were significantly reduced both in stool and in circulation for these mice that were essentially protected from seizures. So those that were receiving the ketogenic diet or that received a probiotic in the ketogenic diet. But then those treatments, so either a controlled diet or antibiotic knocked out microbiomes with the ketogenic diet, those still had high levels of these gamma-glutamyl amino acids. And what's really interesting too is that the effective therapy, so our ketogenic diet and our ketogenic diet plus the probiotics, managed to increase the brain GABA-glutamate ratios, which is really getting to alleviating the pathogenicity of epilepsy and really trying to get at an actual mechanism of how to alleviate not just the symptoms, but the disease itself. So thinking about the metabolomics data, if I'm going to try to reduce all of my gamma-glutamyl amino acids, one way I can do that in the absence of a diet or in the absence of a probiotic approach is to inhibit the rate-limiting step in gamma-glutamyl amino acid formation. So the enzyme gamma-glutamyl transferase, or GGT, catalyzes this rate-limiting step. And there are inhibitors off the shelf that you can use to demonstrate that blocking GGT, in effect, would increase seizures. And that's exactly what these researchers did. They took a gamma-glutamyl transferase inhibitor called GGA-TOP, and they applied it to these mice in the absence of the ketogenic diet. So that's really important that this was done with the control diet. And this inhibitor on its own managed to significantly increase the threshold for seizures. So essentially imparting the seizure protection in the absence of the diet. So bypassing a lot of what the microbiome is doing and essentially reducing our gamma-glutamyl amino acid levels in circulation. So this really gives us a number of paths forward that Metabolinks was able to reveal. First, it commented on the specific mechanism of how the ketogenic diet works through the gut microbiome. It works by reducing levels of gamma-glutamyl amino acids, which in effect increases our GABA to glutamate ratios in the hippocampus and really getting to the underlying problems with the disease. And second, it revealed an actual drug target, a druggable target where we can inhibit gamma-glutamyl transferase and, in the future, maybe inhibit specific gut microbiome-derived gamma-glutamyl transferases and thus not affecting the host. So a real path forward for discovery and drug development in coming up with a brand new strategy for tackling seizures and epilepsy in humans. And the fact that gamma-glutamyl-transferase levels have actually been shown to be lower or levels are higher in patients who have epilepsy. This actually could be a translatable marker, a set of biomarkers as well as mechanism for inhibition to really start taking this into the clinic in humans. So metabolomics gave us the mechanism and our target for drug development. Really cool result.